All right. So good morning, everyone. My name is Andrea, and I have Benjamin here with me. We are part of the application security team in Equinor, and we have spent the past few months working with teams, with development teams, threat modeling their machine learning and AI system. But first, a quick introduction of who we are.
All right. So some context as to why we are here talking about threat modeling, AI, ML. And I realize we started a bit early, but that's turning out just fine. So not in any way unique to Equinor, but we consider IT and software key assets for us in order to reach our company goals. We have just been through a process where we have been moving our stuff into the cloud at an unprecedented speed. And we keep adding to that portfolio. More coders, increasing our code base, and no-code load coders are popping up. And we are coming from not a setting, but a scenario where everything is on the internal network and thus believed to be secure because it's behind the almighty firewall. But it's not the case anymore, and we're shifting security left, which means more is put on our development teams in terms of security. And this whole scenario has a large set of cybersecurity risk associated to it. And in response to that, Equinor started an application security team, and that's us. Our purpose is to reduce cybersecurity risk in Equinor's SDLC. It was formed in 2022. Me and Andrea, we have 7 other colleagues. We're all developers gone AppSec. And the way we try to fulfill our purpose of reducing cybersecurity risk is to act as an enabler team. So we try to offload this added responsibility put on the development teams as a result of shifting security left. And we give them the knowledge and the tools that they need in order to do security in an efficient and sufficient manner. So create a bunch of workshops on important security topics, some of which are open sourced. So please check out our GitHub, Steal with Pride. We write guidelines and where we condense best practices and And we kicked off a Security Champions Network. It has 220 or so champions representing 150 or so teams. And we give this network some added attention with monthly seminars on AppSec topics. We do weekly coffees and physical meetups, and of course, a responsible amount of merch and swag. And we investigate tools and make them available to our developers. And besides doing enabling stuff, we also do some hands-on activities with support in Slack. We help teams set up tools, and we sit in on and help facilitate threat modeling sessions, which is where we got some of the material for today's topic.
Yeah. So for completeness, this is what we mean when we talk about a machine learning or AI system. There is typically a part that is traditional development, user interfaces, API, but also probably pipelines and tests. And then there's a part that is specific about machine learning, meaning that we have a set of data, we have a model that we have selected, developed, prepared, and there is a phase where this model is trained on our data, producing an artifact, which is then deployed together with the development, with the software developed into an operation pipeline, which for us is mostly Azure. Equinor has had a stable group of data scientists, at least officially since 2016. Today, there is a rough estimate about 100 full-time data scientists, and this number is constantly growing. And we have a Slack channel with 400 members with different degrees of participation. On the tech stack, it's mostly Python, some C++, some CUDA. And quite often we see the usage of user notebooks. Of course, as in many other places, we have seen a boom of small and larger initiatives in response to the release of ChatGPT 1.5 years ago. And we have many explorative or learning tasks that are ongoing, and these tasks, security is not always the first concern. As Benjamin said, the AppSec team has been alive for about 2 years, but we never had anything specific for data scientists in the company. We have always focused on software developers. So this is the first initiative. And we picked threat modeling because it's very versatile, it's adaptable to any kind of team and any kind of needs, and most important, it makes people think. So now Benjamin will quickly run through the way that we typically do threat modeling in Equinor, and I'll cover afterwards how we adapted this for machine learning and AI.
Yes. So it's the first activity that we picked up when the team was started. At the time of 2022, this practice was not exactly widespread among our developer community. So as an enabler team, we wanted to put this tool into the hands of the developers, which for us meant to create the workshop, which we did. It's the AppSec Fundamentals Threat Modeling 101 workshop. It's one of the open source ones, so yeah, still with pride. And as Andrea said, it was tailored to the development community, not necessarily AI ML. So I'll walk through the process of how we conduct these sessions normally and the adjustments that we needed or wanted or decided to make in order to also cater to the data scientists. So what we want to leave the teams with is the what, why, when, and how of doing threat modeling. So the what and the why part is pretty much the same. We use the threat modeling manifesto definition of doing threat modeling, where we create a representation of a system, and we use that to highlight concerns about security and privacy. The incentive for doing threat modeling is also the same. I don't think it's a controversial statement that everyone should do threat modeling, as it allows you to develop and operate more securely. It allows you to identify vulnerabilities in your system early in the SDLC, and as opposed to doing pen testing or applying security tools, threat modeling will help you identify issues with your designs and implementations, which is important. And the output you get from this activity provides you with evidence that security is built into your design and not something that's bolted on as an afterthought. And if you do this as a collaborative effort, you create this awesome arena for your team to get a collective understanding of how your system works. And lastly, it gives the teams a consistent approach to security, as threat modeling will guide our designs and help us make decisions with our eyes open. Yeah. As for when, also the same. Data scientists also needs to apply this in the early phases of the SDLC. It's when this activity gives the most value. The way they operate and the way they develop their SDLC should also be subject to threat modeling. It has a large attack surface. There are many things that could possibly go wrong, and these things should be addressed. Purposely used the infinity illustration of the DevOps cycle here to highlight that we keep returning to the early phases of the SDLC, which means that threat modeling is not a one-time activity. It's an ongoing effort. That being said, I'm not saying that everything needs to be threat modeled necessarily. Context matters a lot. Different teams have differences in what level of risk they are willing to accept, and that's fine. But accepting risk should be done consciously, and I don't think you can do that without having a consistent approach to threat modeling. You should do this little and often. Much like using a compass during a hike, frequent threat modeling will help you stay on the right path towards your security goals. Yeah, so it's in the how part things starts to differ. We still answered 4 questions from the threat modeling manifesto of what are we working on, what can go wrong, what are we going to do about it, and did we do a good enough job? The what are we working on step, this is where we create the representation. So the data scientist also needs to do that because we need to know what are we talking about and what will be in the scope of this session. They need to clarify their ideas and create this arena for awesome knowledge sharing. No specific drawing methodology for this, but since we often cater to people new to the practice, we use data flow diagrams, which is not unique when doing threat modeling. It's very useful because it's easy to get started with DFDs. These are the components, not going to go through it. And it's tool agnostic. You can use pen and paper or whatever, point made. So after we've all aligned on what's going on here, we start identifying concerns. So we track the concerns as we find them, along with assumptions that we make. And this is input to the next phase, where we address these concerns. And here we can leverage some frameworks and tools to help us with this step. And this is where things start to differ. We normally, with the traditional development teams, we use striped, which are categories for concerns. But we wanted to have categories that were specifically targeting AI ML systems. And Andrea will go through that in a few minutes. Last up, we address these concerns in one of 4 ways. We can either mitigate a threat, where we add controls or policies. We can eliminate a threat altogether by just removing a piece of code, or it's not just removing a piece of code, but it's one of the things that you can do to address this. Or you can just accept a threat, perfectly valid, or you can transfer the threat, where you buy insurance or you buy some service that handles this for you, or you can have your end users accept it on your behalf. We also indicate severity to help with prioritization, and we check our assumptions in this step. And just to be true to the 4-question framework, we are not normally part of this step. This is a retrospective step that the teams do themselves after they have been doing this practice for some while, where they look back at what they've done and make adjustments so that this activity keeps giving value to them and allows them to keep doing this. Yeah.
So for adapting this process to machine learning and AI, it turned out that the first step, or the most important step, was to identify a set of threats that would be relevant for our data scientists. And in literature, there are several proposals or standards. We have the OWASP top 10s for machine learning, and for LLMs, there is MITRE Atlas that was presented in a few presentations these days, and some others. We were not fully satisfied by this for our threat modeling session, for instance, because MITRE Atlas is very extensive to the point that it's too extensive to be handled in a threat modeling session. And the top 10 for LLMs covers LLMs only. So we ended up creating our own set of categories inspired by this. And the other important step to adapting the threat modeling process was to differentiate between training and inference, because these phases are exposed to different threats. So starting from the training phase, in the training phase, we are concerned with training data manipulation, which is also known as poisoning. In poisoning, an attacker can try to modify your input data so that the model you train the data behaves differently. This is, of course, just a toy example, but poisoning could lead to explicit attacks like this, but it can also be used to cause a more general loss of performance or misclassification in your system, or even worse, can be used to cause a bias, which could have a detrimental effect in the long run. For threats that apply for both the training and the inference phase, we have supply chain attacks, model tampering, and model stealing. This is our reference model for MLDevSecOps. And you see there are several arrows coming from the outside, and supply chain attack happens whenever an attacker compromises one of these elements we get from the outside. On the left side, we have the typical supply chain attacks, which affects libraries. For machine learning, a supply chain attack can affect, of course, libraries, but also the data we are using, if we get it from third parties, or models that we download from Hugging Face. Or again, we might even outsource the training and we are not really sure about what we get back. Tampering and stealing impacts the model after it has been trained or fine-tuned, and the root cause is typically improper access control. So if an attacker gets access to our model or the train in this binary form, the attacker could modify it so that it misbehaves, again causing misclassification, bias, and all sorts of bad things. Or it can just take the model and run away with it, which could be a loss of intellectual property or of competitive advantage. Or it can also be used for enabling further attacks down the line. Notice also that one of the most common file formats for storing this trained model artifact is based on Pickle. And Pickle is known to allow remote code execution, so we classified that again as model tampering as well. In the model stealing category, there is one particular attack called transfer learning, and this occurs when we are exposing our model on a network with improper access control or rate limiting, meaning that an attacker could just use our endpoints and classify their own data and use the data to train a new model. This has different degrees of success. The new model sometimes resembles the one that was targeted, sometimes it doesn't. But we know that this was the way that at least the Alpaca large language models was fine-tuned. This started from a Llama 2 model, and it was fine-tuned using text generated by ChatGPT. And interestingly, last month, OpenAI decided to suspend ByteDance account on ChatGPT because ByteDance was using ChatGPT to train their own model. And finally, moving on to the inference phase, we are to deal with input data manipulation, training data recovery, and insecure output handling. Input data manipulation includes evasion, meaning that an attacker can slightly modify the input so that it looks the same to a human, but the model treated differently than it's supposed to. Prompt injection is typical for large language models, and it's about making the model producing an output that it's not supposed to. And we also have denial of service. An attacker can craft an input for our models that it might make our model or our whole system hang or crash. In trained data recovery, and this typically happens when an attacker has already stolen our model or if our model is exposed to the public, an attacker could retrieve the data that was used to train your model. Given infinite time and infinite resources, this is pretty much always possible. So if you have personally identifiable information in your model, if you have intellectual property in your model, this is a risk. And the insecure output handling happens during the operational phase of your system. And if you open up this box, when some input data comes in, it's typically preprocessed, then it's passed on to the machine learning or AI model, and some output is produced, which is post-processed, and then it goes back to our user. The results produced by the model should be treated as untrusted data. We don't really know well, in some cases we know what the model produces, but just to be on the safe side, assume we don't know anything. So if you are going to publish this content on public venue, make sure you check, because if you publish something inappropriate, you might have a reputational damage. If you just log the stuff the model produced without checking it, you might be vulnerable to Log4Shell, for example. So treat that as untrusted data and validate it before doing anything else. So we have 4 threats that are relevant in the training phase and a total of 6 threats that are relevant in the inference phase. We set up several sessions with various teams. The sessions were 2 hours long, 1 hour where we went through the theory, which is more or less what we explained so far. And during the remaining hour, we talked with the team, identified their business requirements, their confidentiality, integrity, and availability requirements. We helped them creating a model of their system, because we used an online whiteboard, and not all the teams were used to do it. Then again, we went on to identifying and analyzing threats and deciding on further actions. And here we're going to present 4 cases where we ran this process. First case is an internal version of ChatGPT. And we did this because the company was concerned that employees would use the OpenAI ChatGPT and start putting confidential information in that. So they decided, OK, let's deploy our own version and run it internally. Also, there is a plan to fine-tune this model, or, well, work more on this model and include some Equinox-specific data. It's not there yet, but we decided to include it already in the threat model. Confidentiality here represents a high risk. Our user prompts should not be seen by anyone else because they can contain restricted information, while integrity and availability were not the main priority. This is how the model looks like. We have the user here on the top left, which has some user data which is potentially internal or restricted. We have some authentication. Don't bother too much with the details. We have our own, OK, it's dead. We have our own front end, which talks with the Microsoft Chat API. And the Microsoft Chat API also is connected to something called abuse monitoring. So when a prompt is detected as potentially abusive, a human can be dragged in to check the content that was posted there. We know that somewhere, sometime, the fine-tuning will happen with our own data. And we also know that most likely the Chat API rely on a large language model that is trained by Microsoft somewhere. We identified a total of 7 vulnerabilities here. There are probably more. This is just what we came up with in just 1 hour. And I'll present some of them. First of all, the abuse monitoring is an obvious risk. The whole reason why we are deploying this internally is because we don't want people outside of the company to see our prompts, so the abuse monitoring can be a problem. So the action here was pretty easy. We just got in touch with Microsoft, and we asked them to turn it off for our instance. Training is happening somewhere, so poisoning is a possibility. We see that we might get some wrong suggestions. Also, the large language models can produce links, and malicious links can be produced. But overall, we know that Microsoft is doing a good job. Still, even the best make mistakes sometimes. So we decided to account for this possibility that maybe the dataset has been poisoned, and occasionally some malicious links can be produced. In terms of actions, we are going to invest in user awareness, tell people that the model can hallucinate at times, can produce stuff that is malicious, and also when we will fine-tune on our data, we will make sure that the links that we pass in are exclusively referring to internal sites. And the last vulnerability I want to talk about on this is insecure output, because our front end render the text produced by the language model as markdown, meaning that, of course, links can be masked behind an non-malicious word, like click here, with here having a link. And also, it can pull in pictures from the web. if it generates an image tag in Markdown with a link to somewhere on the internet, that image can be downloaded and run on and displayed on our machine. And this is a problem. This happened last September. There was a vulnerability was discovered in the libwebp library, which is used for displaying WebP pictures in browsers. This affected all browsers and most telephones. And it was actually actively exploited for installing Pegasus, this Pegasus spyware on some phones. So this is definitely a problem, and the action here is to whitelist links also in the front end. Just display or like make the user see only some links and remove the ones that you don't recognize. Then, second case. Second case is an automatic seismic interpretation. Seismic is a large set of data, which is often in volumetric form. It looks a bit like the stuff you see down here on bottom right. And we typically have teams of geologists looking at these pictures, trying to figure out what they are looking at. If there is a fault, if there is a pocket of salt, if there is, well, oil and gas, for example, hidden somewhere. And since this process is quite time-consuming, a team of developers and data scientists looked into creating this interpretation automatically. Here again, confidentiality is critical. The access to the seismic data is restricted to a small number of people. This model is not public, is considered competitive advantage for Equinor. And on top of that, the data that we are using for this is leased only for a fixed time period. It's not even owned by Equinor. The model looks like this. We get a pre-trained model from somewhere that I was not allowed to disclose, and we get a new trained model about every 2 months, if I remember correctly. We have some administrators that just install this model on our Azure tenant. And the way that user interact with this is in 2 steps. First, the user that works on a specific asset, depending on where they're placed in Norway, have some additional data that they can use for fine-tune the pre-trained model. And then they have some other input seismic that they want to classify. So the user will first create a pre-trained model using its own specific training data, and then it will start feeding in the input seismic to be classified. This goes through an API and the job dispatcher that runs stuff on Azure. The result is saved on a blob storage, and the user gets notified when the results are ready. Again, we got 6 vulnerabilities here. And of course, on the top part, we recognize that we have potential for supply chain attacks and or poisoning, because this is done by an external entity. However, after some discussion, we decided to accept this risk. We trust this external entity, and on top of that, the impact of what could be done here with a loss of performance or bias is negligible. And that's because the user will get to see this interpretation, and in this case, the user is a geologist, and it's able to recognize if an interpretation is off, hopefully. On the fine-tuning and on the inference part, there is an opportunity for denial of service. There is already a limitation on the size of data sets pushed in and on the model, and that is given by the amount of memory that is allocated to the virtual machine. But during the threat modeling, the team realized that they never implemented the rate limiting, so a user can potentially start 200 jobs, and that would pretty much block the entire system. And of course, the mitigation here was obvious: implement rate limiting. The most serious issue was detected on the admin role, because if the credentials of the administrator are leaked, then the model can be easily stolen, because those 2, 3, 4 people can just get access to the model, and that access is not kept track of at the moment. So the actions here included classic improvement to access control, including enforcing two-factor authentication, which is already in place, revisiting the list of administrator, just-in-time privileges, and access only from some specific devices. We also decided to look into the possibility of encrypting the model, but this might come with some practical limitations, so we'll see what to do here. Benjamin. It's dead.
Is it?
No, it's not.
Okay, good. Right, so third up is the MLOPS platform. So this team provides a platform for the model providers where they can host their models in a compliant, efficient, secure, and observable manner. So that they regard the models and the predictions to be of an internal classification. They figure that the models should be protected from tampering to ensure integrity. And as for availability, they know that some of their model providers needs the predictions available in certain time slots. So they will inherit this requirement from them. This is the diagram. So I'm going to do this. I'm not going to do that.
No, don't.
All right. So the MLOPS team are the admins here, and they have multiple teams using this platform. So that's why there are 2 users, and everything is duplicated to represent multiple instances. So the model providers provide their models to this platform on Azure ML. Training is done on the platform and is using some shared repository for training data. Models are deployed, predictions are made, and made available to the end users, in this case, traders. Yes. We also came up with some threads, again, duplicates, because duplicates. And they too recognize that this shared repository for training data could be manipulated, which would result in wrong predictions and then possibly some missed opportunities for the traders. And their strategy to deal with this was to transfer the risk over to the model providers, and have them accept it on their behalf. Their main thing was insecure input manipulation, so that this is a result of them having very high trust in the artifacts provided by the model providers. They will run these artifacts unchecked on their platform. And this could result in a lot of compute power being used, which again results in a high bill from Azure. Or in the worst case, it can eat up all the resources and make the platform unavailable. So their fix for this was to double check their logging and monitoring routines and set up alerts for unexpected high usage and try to catch this if it should happen. Last up is the trading recommendation system. So this team is one of the model providers that provide models to the platform that we just saw. So they make a system that makes trade recommendations to traders. They consider their model to be confidential. Same goes with some of the data that is fed into this model. The output that this model creates is considered sensitive in a short time span after it has been produced. And for them, integrity of the predictions are critical because traders will not be able to tell if a prediction is right or wrong in any way. They did not have any hard requirements for availability, but they figured that it should be up because if it goes down, there are possible loss of opportunities. This is a diagram. It does look and should look very much the same as the last example because it is the same platform. The things that have been added here is the development stage from the model providers. They also wanted to depict this cache that they utilize, where some of the training data from the shared training data repository is cached for audit purposes. Else, it's the same. The models are deployed and predictions are made available through some training platform or by email. Yep. Discovered some threats, mostly focused around the deployed and training part. And the main one was model stealing, because they recognize that there are multiple teams using this platform. And since they can access other teams' models, in turn, maybe they could access theirs. So permissive access control on the platform that they're using. So how they wanted to address this was to simply ask the MLOPS team to implement stricter access control. They also identified training data manipulation, but as opposed to the previous team, this team don't have the option of transferring this risk to someone else. So the way they wanted to deal with this was to utilize this, this cache that they already have in place for other purposes and try to compare it to new training data in order to catch any manipulation. And they will also continue to explore strategies for dealing with this. And rounding off with a traditional good old supply chain attack with good old malicious dependencies and unauthorized access to the repositories. And the fixes are known. Remove unused dependencies, utilize scanning tools, and just apply best practices for GitHub. That's that.
Yes, so as a summary, we went through 4 cases where we did threat modeling specific for machine learning and AI. We covered several classes of threats, and we had about 30 threats identified in total, with training data manipulation being the most frequent, not necessarily the one with the highest impact, but all the teams actually recognized it, followed by supply chain attack, tampering, and input data manipulation. In conclusion, again, training data manipulation was the most frequent. Why was this? These teams were not used to do threat modeling before. I think one of them did 1 session before this. So it might be that we have oversold our case, how dangerous training data manipulation could be. This is an article from last year, and indeed some people seem to think that poisoning is either unpractical or unfeasible. On the other hand, the way we treat and we handle our data is still a high priority. So we should just keep watching this area and maybe take decision 6 months, 12 months down the line. Another interesting conclusion here was that all the mitigations that were identified by the teams ended up in the category of traditional application security in the form of allow list or deny list, input validation, rate limiting, software composition analysis, etc., etc. And none of the team actually considered to make changes to their machine learning or AI model to reduce the risk. Why is this? We don't know. For sure, with application security, you go a long way. And this is actually consistent with the conclusion of another talk we had yesterday from Sarah Young. On the other hand, it's still a very early stage. It might be that in the future, we will find better ways to embed security into the machine learning models themselves, so the situation might change. You want to do the last part?
I can. So other reflections are now catering to the data scientists. It was really good. They are used to their models misbehaving. So this whole process of what could go wrong felt really natural. So that was good. We did notice that the differences between teams, if they had turnover or if it was long-lived really impacted the effectiveness of these sessions, which doesn't come to a shock, but it was noticeable as well. They were good, but yeah, noticeable. We did 2 hours for this, and that might have been a bit short, but it's a fine line to balance. Had we gone any further, done it longer, we might have discouraged the teams to pick this practice up on their own. And because in general, it is a struggle getting teams to adopt this practice on their own. We don't get me wrong, we do have success stories on this. Some people see the great value of doing threat modeling, but it's yeah.
We need to work on that.
Yeah, we need to work on that.
So that was all. Thank you for coming.